Weight is very important, so swap out your old chunky speed controllers for modern multi-rotor ones. Much like the concern with motors overheating, a continuous, relatively high power draw on the battery may be more demanding than you expect, so also make sure your batteries are up to scratch. You may have problems with signal dropouts and interference if your antennas are too close to the rest of the electronics inside the hull. So do what I did here, and you may have to mount the antennas outside. Unless it's a very light model, just use digital Metal Gear servos, trust me. These are Hextronic MG14s, which also go by another name, or at least there's a very similar servo which I will put on screen. Keep your diameter to pitch at least 2. If you go too steep a pitch, you'll stall the blades and your hovercraft will consume much more power, hover lower, and probably cook the motor if it isn't already. Multi-bladed propellers seem to be quite good, but it's very hard to find them in the right diameter, pitch, number of blades, so you might not actually get a chance to use them very much. You need cooling airflow past the motor and through the motor. So just simply having the motor sitting on a base plate with no stability port underneath it is not a good idea. I have done it on a previous model and moved away from it for very good reasons. If for whatever reason you decide to experiment with this, just be aware your motor has practically zero cooling because the airflow is just going to be thrown outwards, so do account for that. I have very little experience with an inverted motor mount, with the motor effectively out of the hull and above the motor. I know people have done it, but my intuition says the motor cooling is going to be pretty poor, and especially with a big motor, it's going to push the centre of gravity quite high, and it makes the structure much harder. My early builds used the ESCs I had sitting around, which are plain ones, as in airplane. And for a single motor craft, there's nothing wrong with them. You need enough current capacity, you need a BEC to run the servos, so I wouldn't have an issue using them in a single motor craft. As soon as you add multiple motors, especially 4, but even only 2 motors, if you keep piling these in, you're going to have a lot of weight and completely redundant BECs. It's very wasteful. And as I will be covering shortly, weight is so incredibly important. Anything you can do to shed it, absolutely go for it. And one of the easier things to do nowadays is just swap out the old style speed controllers for modern multi-rotor ones. That's about 25 grams versus I think about 8 there, or something like that, even taking into account the wiring weight. So 4 of these plus a BEC is a really quite significant weight saving over 4 of these, and even if you think, oh, it's only 50-60 grams, yeah, when you get to building what I'm doing, very light craft, very high hover heights, it absolutely makes a difference. And I wish I'd done it sooner. I've spent a lot of time reducing the weight of structure, which is a perfectly viable thing to do in itself. It's not a waste of time, but I remember swapping out speed controllers and just massive increase in, okay, not massive, pretty substantial increase in hover height for effectively no actual structural work. One interesting thing about the multi-rotor ESCs, they're designed to be used with multi-rotors, so flight controllers, so no throttle damping, and as quite a few people have kind of commented before, do I use flight controllers? No, all of my motors and flaps are just manual control, no gyros, no auto level. However, I'm just starting to experiment with it, and using these gives you the option of using something like a flight controller or a gyro, because there's no throttle smoothing. These would work with that with no issues, whereas a traditional plain ESC, it's expecting a kind of human input, so it's going to have throttle smoothing and whatnot. So the only disadvantage of the multi-rotor ones is no low voltage cut-off, so definitely keep an eye on your voltages if you're using them. Following on from what I said about motors, about constant power draw with little cooling and high loading, the same broadly applies to batteries, and that my single motor craft, which I'll put on the screen if I remember, that's 5 amp hours against 35 amps draw, so that C rating's quite low, doesn't really present any problems, but my twin motor one, which I will put on screen if I remember, that is a constant 26 amps at full throttle versus a 2.2 amp hour. That constant 12C draw is possibly more stressful than you may imagine. A lot of aircraft spend their time at maybe 5, 6C loadings, occasional burst to 10, that's what a lot of mine do. But, like I said about propellers unloading, this hovercraft draw could push a marginal battery too far. So, much like keeping an eye on your motors, keep an eye on your batteries, and if you've got some, like this one, which are really getting on a bit, I relegate these only to my very low drain craft, and certainly my twin motor hovercraft is on the more modern, higher C rating. I know it can cope with it. Certainly much less voltage sag. And indeed, few people seem to warm their lipos, and I seem to be one of few people that don't have them dying every winter and having terrible performance. So, once again, that constant 12C draw is really going to wreak havoc on a cold battery. So anything below about 15 degrees, or maybe 10 at an absolute maximum, I'm going to warm these up. And you better believe if you're running down at freezing or 5 degrees, putting a cold battery into one of these things and immediately trying to draw 12C from it is really bad. Especially because it's not even going to get much of a chance to heat up with the coolant airflow from the propellers. Which leads to a whole discussion about should you have the batteries in a separate compartment. And on the subject, definitely have the ESCs inside just open to the airflow, that's kind of an obvious one. I have built craft with internal compartments, waste of time, just keep them hollow. And much like I was saying about multi-rotor controllers, no low voltage cutoff, I see no reason not to run telemetry these days. And your constant high C rate's going to pull your power down quite quickly, so definitely keep an eye on the voltages closely. I don't know if anybody skipped the intro and just came straight to this section, but I might as well reiterate, I have had trouble with signal dropouts on my twin motor one, which ended up with a ridiculous amount of servo cables, becks, light controllers, etc. on the inside, and having the antennas just stuffed in there, it was basically unusable, constant dropouts. So I ended up just raising one up out of the hole, and that solved the problem. If you're talking a couple of somewhat nearby servos, it seems to be okay, but it's very frustrating having something which is almost working but constant signal dropouts. Likewise with servos, I've moved away from plastic gear in these. It's very light craft or a very lightly loaded control flap, maybe. But for primary flaps, just go digital metal gear. You don't want slop, you don't want them struggling to open and close against air pressure, you don't want... If you do catch the ground or hit something, you don't want to strip a servo. So, again, it's Hextronic MG14, also known by another name, it's like Tower Pro MG something. I'll put it on the screen if I remember. And I've never seen a need to go above the kind of 14 gram size, seems to be perfectly fine on these large flaps. So, let's talk propellers, and the argument that they might not be the best to use in that a propeller is designed to propel, it's designed to push air back against free air or a very minimal obstruction in the form of a fuselage or a wing. What we're trying to do in these hovercraft is hold back air against pressure, or well, we're trying to move air through the hovercraft, but necessarily there's back pressure. So the air's not getting pushed cleanly back, it's getting pushed in and then immediately trying to come back out again. And the argument being that a fan, as in centrifugal fan, I can't pronounce that, might be better. And as I'll be saying a lot in this, the difference between what is theoretically better and what is practical, I have thought about 3D printing a centrifugal fan on a smaller craft, maybe on a 100 watt motor. There's absolutely no way I'm doing it on the 400 watt one, I'm not doing that. But fan design is literally an entire art and science in itself. There's people whose entire job is just to wrangle with centrifugal fans and airflow, so I'm not going to claim I can do any better of a job. At least with the propeller you have a reasonably well engineered existing solution that you can trust, so you can optimise the selection of propeller rather than trying to optimise, a custom centrifugal fan or blower, trying to optimise it by itself and also against the operating conditions in the hovercraft. But I would like to see, and if I had more time I would, some sort of 3D printed blower, centrifugal fan, mixed flow fan. I wouldn't claim that a propeller is optimal, but it's good enough and easy enough. I think certainly the local saying is teaching your grandmother to suck eggs, which is to say I don't want to explain things which I assume most people watching this already know, partly because it's patronising and partly because you've probably listened to me enough and it's filling up the video. Nevertheless, a propeller has a diameter is pretty unambiguous, pitch is complicated, I'm not going to elaborate on it, but broadly pitch is the steepness of the blades. Speaking of propellers, there's now an aircraft about to fly overhead, so I'll be back in a minute. So here's a stand-in for a propeller blade. Imagine the axis of rotation is, coming out of the table like so. With a zero pitch, it's not going to do anything. There'll be a small amount of drag, it's not going to shift any air. If you had I guess you'd call it an infinite pitch or 90-degree pitch, this will do something. It will move a lot of air and it will consume a huge amount of power, but it's not actually going to give you any thrust. It's going to be more like a centrifugal blower. So if you're trying to move air this way, it's not any good. And that notion, it will consume a lot of power but not usefully, is going to come up in these hovercraft. It's not about power, it's about using it efficiently. So you can have something drawing a lot of power. It's powerful, but it's hardly lifting, because much like a 90-degree blade, it's just churning up air. Well, you're not going to put an actual 90-degree blade on unless it was specifically meant for centrifugal flow. Typically, pitch to diameter, diameter to pitch, I'd say, of 2 to 1. 2 to 1 at a minimum, which is to say a 10x5 is okay, a 10x6 is going to stall. Again, eCalc will give you a guideline on this. eCalc will give you a guideline, which is pretty accurate. Now, within the hovercraft, because of this back pressure, okay, I'm trying not to go into too many tangents here. This is a 9x9, which would be stalled at 0 airspeed. The pitch on this is such that everything was just sitting here spinning. It's almost quite close to the theoretical 90-degree blade. It's going to consume a lot of power and it will be churning air but not necessarily throwing it backwards very effectively. So you say, why use it on an aircraft then? As forward speed increases in an aircraft, and remember it doesn't in the hovercraft, the oncoming air, it effectively has less pitch. I know this is kind of simplified and there's whole university courses on this kind of thing, but because it's going through moving air, it unstalls, and then it generates more thrust. The power consumption may or may not change. Again, it's complicated. Just because it's stalled at 0 airspeed doesn't mean it's useless on an aircraft, because an aircraft isn't going to have 0 airspeed. But again, on the hovercraft, you don't have that luxury, so if it's stalled, it's always going to be stalled. And I mentioned that in a plane you've got oncoming air, which reduces the effective angle of attack. It's as if the propeller blades are becoming flatter. Well, hovercraft, because you've got back pressure, it's kind of the other way around. And a propeller which is maybe marginally stalled on an aircraft is probably going to be stalled in the hovercraft just because of that. Instead of air coming this way, lessening the effective angle of attack, you've actually got air coming, trying to come back up and raising the effective angle of attack. So using a propeller in an application where propellers maybe not best, this idea of trying to hold air back, yes, you're trying to move it, but because this is pressurised, the air's trying to come back up. And one idea is the kind of solidity, it's called, of the propeller disc, which is one way of thinking. On a two-bladed propeller comes by, it pushes air down, but when the blade's not there, there's nothing stopping it from trying to come back up again. What's stopping it is the fact that you're counting on the propeller blades coming by so rapidly that the air doesn't really get a chance to come back up before the next one comes along and bats it back down again. So, kind of clear that adding another blade really helps, and you can see solidity. It's like, okay, I kind of get it, but the idea that it's less time until the next blade comes around, it helps kind of keep the pressure back, improve airflow. So why not just have a 4, 5, 6 bladed prop? I'd love to if I could find one, or at least like to try it. You know, the relationship between RPM, diameter, pitch number, blades, back pressure, it's going to be really complicated, and the sort of thing I can research with certainty here. I would like to try a 4-blade, but they start at far too high pitch. This is it's a 10x5, it's a master air screw 10x5, and every manufacturer's got a different way of how they measure pitch. And I tend to think this looks a little bit less pitch than I'd expect for 5 inches. You know, just while I'm here, that's a 9, okay, it's a 9-inch, but that's a 4.5. And yeah, it almost looks as if that's actually got less actual kind of practical pitch, even though it's apparently 5 inches. So maybe that's why I'm getting away with this, whereas I think a 10x5, a steeper interpretation of 5 inches would probably be stalled in here. So, you know, a 10x4 4-blade would be great. They don't exist. I'm lucky even to find this, all of these multi-blade propellers start at far too high a pitch for these Hovercraft. So that's why, on paper, you can criticise the use of a 2-bladed propeller. You're better off with something more solid, you're better off with the fan, yeah, but in terms of what I can practically buy, this is good, it works well enough. This craft performs very well, in my opinion. It's a good match to... It's a really good match to that motor as well. Expanding on motor placement, and speaking of motors, this propeller's currently on upside down because I was trying to illustrate the possibly having the motor mounted above, which I've seen at least one person on RC groups do, so I can't tell you it's a stupid idea, it doesn't work. But I think motor underneath, better cooling, very easy to put it onto the base plate. The only thing which was raised in RC groups with, if you're running on salt water, you're going to get spray up into the bottom of the motor, which I've ran on water before, ran on salt water once. It didn't seem to be an issue for me. I had the motor quite bolted onto a plate, and the bottom seemed to be quite well sealed, and if it's a case of replacing a bear now and again, maybe spraying it down. But I just thought I'd raise that. And by the way, this particular combination, this is just a motor I pulled out the drawer, you know, 2826, 400 kV. This with this propeller would be really pushing it on a plane. Absolutely no way this is going to work on Theus and Hovercraft, but for illustration purposes. So if you just had it sitting on a base plate, this is going to have no stability jet cut. This is going to cook. And I'm waiting for somebody to pull me up on my use of centrifugal force, so, you know, I can post that XKCD that everybody always posts, but, you know, a combination of centrifugal force and the airflow just naturally trying to equalise out. You know, it's going to seek the low pressure, it's going to seek the peripheral jet. So, if this thing's sitting without a cutout, it has practically zero cooling. So, it's just going to push your motor temperatures way too high. It'd have to be a really, really over-spec motor or some sort of additional cooling fan or setup, but at that point, you know, if you're thinking I'll just duct off the propeller, you might as well just have the stability port there. A general thought about propeller size. On fixed wing, certainly for low-speed aircraft, efficiency is about large propeller turning very slowly. I don't see that applying to these hovercraft, and it keeps going back to trying to hold that pressure back. You know, it's a 12-inch propeller, and if this was on 2S and turning very slowly, it's too much time for the back pressure to start leaking back past the blades. Now, but perhaps I remain to be proven wrong, but I'd be very surprised if a very slow-turning large propeller might work brilliantly in free air in an aircraft. I don't see it working very well here, even though it's efficient in free air. Doesn't translate to useful in a hovercraft. The application's too different. I have almost no experience on 2S. I had a very small craft with, I think it was an 8-inch prop on 2S, and I think 1000 kV motor, I can't remember, and yeah, it wasn't even about power of the motor, which wasn't much. But just the fact that you just felt like the disc, the solidity of it was too low because of the slow rotation speed, quite apart from not having much power. It was that power not being used very